Amazing experiment on double slit experiment, part 1. Are electrons particles or waves? The oscillation of the water surface forms ripples, with peaks and valleys. If there are two waves with the same frequency, the superposition forms interference of the waves. But have you ever imagined that electrons themselves would also interfere? Scientists once conducted an interesting experiment, but the results were surprising. Prepare a baffle with double slits, an electron gun that emits electron beams, fly them towards the double slits, and a screen for receiving electrons. Can you guess what the result will be? If you treat electronics like basketball, it's like shooting into a crevice. You must think the result is like this. But scientists have found that the electron beam interferes and becomes a wave when passing through the double slit. Scientists are confused because electrons are not waves, they are electrons. How can interference occur? Scientists speculate that too many electrons may have caused them to wander around, so they began emitting individual electrons. They found that after a single electron was emitted, an electron was indeed seen on the receiving screen, indicating that the electron is indeed an independent particle. But when scientists continuously emit a single electron multiple times, they get exactly the same result as before when emitting an electron beam. Why do multiple electron movements exhibit wave-like characteristics? Can it be said that there is no road in the world, and with more electrons walking, it becomes an electron wave? Scientists are eager to know how these electrons move, so they added an observer behind the double slit baffle to study the trajectory of the electrons. Strange things have happened again. Because the result you initially envisioned appeared on the receiving screen, the electrons did not interfere. Scientists have repeatedly experimented and found that with the addition of an observer, electrons lose their wave-like characteristics and become solid particles. As soon as the observer is removed, the mischievous electrons begin to interfere like waves, meaning that a single electron passes through two slits simultaneously. Diswilling scientists believed that the observer was interfering with the movement of electrons and decided to upgrade the experiment again. This time, they used a more covert method to label particles and observe the path information of the marked particles. In this set of path observation instruments, scientists can freely decide whether to observe its path information or erase its path information. The result was no surprise to the scientists. Once the path information is observed, electrons follow the rules and regulations. Once the path information is erased, electrons will interfere. Scientists decided to launch a surprise attack on the moving electrons before they reached the screen after passing through the double slits. As a result, the electrons, which were supposed to be interfering in motion, became mere particles in an instant due to the scientists' observation. This experimental result breaks the traditional law of causality, making it impossible for scientists to explain it using consistent experimental principles.